One way to think through counting problems are to use trees to help visualize the problem. So I'm going to start out with a really easy example, and I know it's stupid, but just stick with me. So if you want to think about all the unique ways to flip 2 coins, we can honestly just kind of brute force this and think about all the possible options. So we can have heads, 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 tails, tails, heads, and tails, tails. So we have 4 ways to flip 2 coins. So another way you've probably been taught how to solve this problem is to use the product rule. So we know there are 2 events, so flipping coin 1 and flipping coin 2. And for the first coin, we can either flip heads or tails, so there's 2 options. And the second coin, we also have 2 options, heads or tails. So this is 4 ways to flip 2 coins. And the other way to think of this is as a tree. So say we know we have 2 flips, so flip 1 and flip 2. I guess I should say coin 1 or coin 2. And so if I start out, I know I can either flip heads or tails. Now, if my first flip was heads, I can either flip my second flip heads or tails, and the same. So this is literally just what I had before. So if my first coin was ahead of my second one, that's like this. And you can see with the tree how we can write out all of our options. So I'm just color coding that here to help visualize that. And so we can just count out the number of leaf nodes, and that is just 4 ways. So kind of stupid, but it gets more useful for harder problems. So here's our other one. How many bit strings of length 4 do not have 2 consecutive ones? Now remember, bit strings are just strings with only ones and zeros in them. So if we have the length 4, basically something like this would not be a valid string, right? Because we have 2 consecutive ones. So let's think this through as a tree. So we can have our first digit to either be a 0 or 1. And then our second digit could either be a 0 or 1 as well. And then you might be tempted to do this, but if you notice, we have 2 consecutive ones, and we don't want that as an option, so I'm actually not going to include that in our tree. Okay, let's continue. So we can either have 0, 1, and we just keep going, and every time we get 2 ones in a row, we don't want to include it. And then we need to do one more level because we have a total of 4 possible digits. 8. So yeah, I'm just counting the bottom here. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ways to meet this condition. Okay, here's a bit of a trickier problem. So say we have a playoff between 2 teams, and it consists of at most 5 games. And the first team that wins 3 games, it doesn't necessarily have to be 3 games in a row, they are going to win the playoff. So how many ways can this playoff occur? So we can basically have the levels of our tree as a different game. And we can have at most 5 games. So, okay, let's think of our teams as let's just call them A and B, just for simplicity. So we can either have, for game 1, A wins or B wins, right? A or B. And actually, let's make this quite a bit bigger because this is going to be quite a big tree. Yeah, a little spoiler. Okay, and so second game, we can also have A and B win. And I'm just going to continue this thought process. Okay, so A or B for each game could win. Now, look, remember with our options, so the first team that wins 3 games in a row wins. So we have here, in this scenario, we have A winning 3 games. So we can sort of say like this is a stopping point, and as well that's the same here. So both of these parts are done, and let's just continue this process. So A and B until we realize, oh hey, look here, we also have 3 A's in a row. So we're also going to stop at this node, or at this leaf. And again, just continue until you notice there are 3 in a row. So again, we have 3 A's in this option. Oh, look here, we have 3 B's in a row. We have 3 A's here. And I'm just continuing this process. Nothing too complicated. Again, we have 3 B's. Oh my gosh. This is getting kind of messy. Hopefully you can still, oh sorry, because this is finished, we don't care. We already know B won. Let's see, we have three B's in one outcome. Okay, now we're going to continue for game 5. Okay, and now we can just see that actually all of these leaf nodes are going to be winners, because like say for this, we have 3 A's in a row, we have 3 B's in a row, so I can just color the rest of these. And now what I'm going to do is I'm going to count up the amount of orange nodes. So that is 20 possible ways. So yeah, hopefully this is a bit clearer, but you can basically think of like traversing from root to leaf as like a possible outcome. So like, for example, for the heads and tails example I gave earlier, we had heads.